Let's take a hands-on look at some of the newest and coolest tools available in large-scale data processing. Today we're going to dig into an example using Snowflake Data Warehouse and Databricks. These can supplement your current environment for scalable, fast processing when needed, or can be the foundation for a modern cloud-based architecture. Snowflake is a massive parallel processing, or MPP, database that was built as an entirely cloud-based data solution, meaning no hardware, servers, or maintenance needs to be installed and managed. This means queries that run against Snowflake can use multiple compute nodes to rapidly compile and return data. This makes it easy to set up and manage, quick to query, and can scale based on storage and compute needs. Apache Spark is a unified analytics engine for large-scale data processing. It handles large workloads at very fast speeds, and can be interacted with using Java, Scala, Python, R, and SQL. Databricks is a platform built on Spark that provides a user-friendly interface to set up a reliable data lake for storage, collaborative notebooks to explore data and share insights with any of the Spark languages. Data pipelines and machine learning models can be developed, tested, deployed, and automated all within Databricks. First, we need to go into our Snowflake environment and set up a few things. After you've set up your login and get into the Snowflake portal, you'll need to go to warehouses. These are not data storage, they're essentially the compute we will use to run SQL. Let's create and enable a warehouse. Then we'll need to go to databases and create a new one. In this case, I'll name it Airline Demo. Now let's switch over to Databricks. The first step we need to do in Databricks is start up a cluster. This gives us processing power to run anything within Databricks, essentially the same as the warehouse in Snowflake. Next, we'll go into the Data tab. If your data is stored in AWS, Azure, or a number of other integrated file stores, it's very easy to connect to that data. If not, it's possible to use Scala or Python to get data from your preferred storage. In our case, we'll just load the files directly into the Databricks DBFS using upload file. Now we'll create a notebook to work in and connect it to our cluster. First order of business is setting up the connection to Snowflake using the built-in Databricks connector. Setting standard database info like user, password, Snowflake URL, database, schema, and warehouse. If you are on a licensed Databricks, you'll want to look at dbutil secrets to secure your credentials so your workspaces are shareable. Next, we're going to load our stored files into data frames to work with. In this case, we're going to use infer schema since the files contain simple data types. This can be set to false if it's preferred that all data types are set to strings. The data can also be manually defined in a variable and used. This could be a good option if infer schema is slowing down the file read. Next, we'll load the flight data, which has been partitioned across multiple files. So this will be put into a list and the data frame will load from all the files within that list. Just another variation to get the data. Now let's load our data into Snowflake. This could be expanded out into an entire ETL process from source to warehouse, possibly doing all the transformation within Databricks or loading it into a staging table. In our case, we're going to load our data frames directly into Snowflake. We'll use our created Snowflake connection, name the table we want it to load into, and set the mode to overwrite so we can rerun it as we want, but append is another good option we could go with. Once complete, our data will be in tables created within Snowflake. So let's assume that Snowflake is now being used as an operational data warehouse. A number of views have been created based on commonly requested data. How do we explore that back in Databricks? Using our Snowflake connection, we'll read data from a query to a couple views we've created within Snowflake. You could also do ad hoc queries to explore data. Then we'll load that data into a view within Databricks. This is a temporary view that acts like a Hive table. Think of it as a temp table in a traditional database. Once the Spark session ends, the view will be dropped. But the advantage is we can directly use SQL against these temporary views. If you found data during exploration you wanted to save for later use, it could be saved as a Spark or Hive table as well. Now we can run SQL against our tables to explore the data as we wish. In this case, we'll look at the top airport Southwest Airlines operates out of. There are also built-in quick visualization options. We'll also look at the on-time success rate for each of the airlines. This forms the foundation of a data solution built on Databricks and Snowflake. From here, Databricks workbooks can be created and automated for ETL solutions. Snowflake can be expanded to a full enterprise data warehouse with reporting and data integration. Databricks can then also be used by data science and machine learning teams. There's a lot that can be done and it's very easy to set up and test out for a proof of concept. Thanks for watching. If you enjoyed this video or learned something, a thumbs up would be really appreciated. Stick around for more data content by subscribing to the channel or clicking a video on screen. See you in the next one.